Hello, everyone. Thank you for coming. This is webinar number 52 of our series. We're gonna. I have started to make plans to go ahead and do webinars completely through the end of the year. So that'll either make some of you sad or some of you happy. But I have started to really fine tune the co-hosts. I've invited a lot of people over the last couple of weeks, and I think you're going to be pretty excited about some of the people that we got coming. Some people that have already said okay, some pretty big names, not just from the data world, but other places as well. I think you're going to enjoy some of the people we have coming up. We will take Christmas week off, obviously, Thanksgiving, and Election Day here in the States, so just to kind of let you know exactly where I think we're going to go. So, but other than that, every Tuesday and Thursday here on the channel. So keep that in mind. Please continue to join us. This webinar, a little bit of a background. The webinars, every 3 or 4 weeks, we end one webinar with a poll and give people a list of 7 or 8 different webinars that different topics that they may want to see. And I did that a while back, and we have hit the first one, which was tips and a little bit deeper tips and tricks in Ray Studio 2 analysis. And then the second place vote getter in that particular poll was suspension analysis, which we did. And the third place one was engine RPM analysis. And so I've been waiting for either a cancellation of a guest or an open hole in the schedule, and today is that day. So engine RPM analysis is what we're going to talk about. I've been teaching this function in our seminars and on phone support and emails. People ask about it quite a bit, and it's a feature that with some knowledge in the background of it, it can provide some good value. And while you also at the same time need to realize that we're calculating something, right? And there are things that are fighting against us to get exact numbers compared to like what you would get in a engine dyno or a chassis dyno. So as long as we understand these things and understand the basics of how this works, this particular function can give you some value. So we'll look at it a little bit. We'll talk about it and take a lot of questions, and I'll give you the pluses and the minuses and allow you just to begin to really use your judgment on when you should use this function and when you shouldn't. And I'll even give you I had to dig around a little bit, but I found the data that when this function first sold itself to me, and when I started to become a stronger believer in the function, and I've used it a lot since. So I went back and found that data, and we'll look it over as well. So perfect. So let's jump into the next slide. Just a quick introduction. I've done a couple of these when I do them by myself, and I'd like to give you a little bit of an idea of what the background is with me. And I've been a motorsports guy for a long time. Since I was in my late teens, I was my father would take me out to the drag strip that was near our place here in Washington State, and I was watching stuff whenever I could on TV and listening to it on the radio. Yeah, I'm pretty old when Indy 500 used to just be on the radio, especially live in our area, and I really enjoyed Indy cars in that era. And but we decided to race off road, and so we kind of got into that when I got old enough. When I turned 16, I started to race off road cars, and did a lot of that in the upper left hand corner. It was probably in the early 90s, and down in Northern California at the same track, Prairie City ORV Park, down at the same track that has the Hangtown Motocross, is where that particular picture was taken, and enjoyed that a lot. Did really well in that. Did it for about 20 years. At the end of when I was racing, I even did a little bit of circle track racing here in the upper right. Really enjoyed that with a friend of mine, Ron Hart, right here, and that's me getting out of the car on the other side. Really enjoyed that too. Wasn't too terribly good at it. It's a bit of a different skill set when you, like all of you probably knew well before me, but off-road, like motocross or some of those things, the harder you drive and the more aggressive you are, the more you get paid off in speed, and the occasional tumble, but you could make some speed. Where in the in the circle track car, when I took that same method over, and this is another reason that I love to look at data and try to understand overdriving a car, is because I was the master of it in the circle track. I would, you get a little bit behind, or somebody, catches and passes you, you're trying to catch the guy in front. I would just drive it into the corner harder. And on pavement, and especially on circle track, when you're right there at the edge, it all of a sudden the car would just wash up or push, or you go loose and go to oversteer. So circle track taught me a lot about driving within the range of what's available, and that really has helped me a ton. So, and then yeah, the old rabbit, and then my son started racing, and we got into go-karts with him, pretty young, and then moved into some sports car stuff. He did some legends and bandoleros, a little bit of circle track stuff as well, and then got into spec Miata. We chat a lot here about spec Miata, and in the seminars I do on site, and there's so many people that race Miatas, which it's kind of cool, and so we bought that in 2005, and won the Northwest region points series around here, and then 2006 went to the first national runoffs with the spec Miata. Was a national class, and ended up in Topeka, Kansas, and ended up winning the SCCA runoffs. And that's a picture of the victory lap, where they let the crew jump in and hold the flag and drive around. So I'm sitting on the floor over there, and he's driving way too fast, and we're arguing like dads and sons can argue, just normal stuff in the big moment of victory, right? So and then I ended up kind of changing directions, and ended up coming here to work with AIM, and just been a great time. I think it's been great for both of us out here doing seminars, and of course these webinars and all sorts of stuff. So it's a pretty good time. And this was a seminar that I gave in downtown Philadelphia at VAC, the BMW aftermarket group, builder of BMW parts. So the great times there. That's my nephew Robert sitting there, who lives back there. So a little bit about my background. I know I've gone out over a couple times before, but it's always fun to tell some stories like that. So the what are we going to do today? Well, we're not going to spend a ton of time in the presentation materials. We're going to jump right into the live data, and start to chat about what we're doing here. So let me bring up a new share, and let's talk about. Oops, let me do that again. There we go. Let's talk about the engine RPM analysis function. We're going to get there, but I want to set the platform a little bit. I want to get you some information of when you might use this. Some of the basics of what you want to look for. Is the track you're running on a good one for this? And we'll talk about some of the ups and downs, and then we'll jump into using it here in the next 5 minutes or so. What I've got is some data here, and the data that I've got, it's older data. This is the data that sold me on using this function a little bit more than I probably had in the past. And this is from a track in Utah. Miller Motorsports Park is where it's at. This is old enough data that it didn't even have GPS data in it. So we've got the standard track map, still works great. But this long straightaway right here at Miller is a fantastic place to use this particular function. When you have these environmental things coming at you that will affect how we calculate horsepower, because all we're doing is we're taking your data, and we're providing a bunch of formula in the background that our friend Emiliano, who is here in the panel in the background, is they do all the math, and they calculate from your acceleration rates and using all the channels that you have, mainly RPM and speed, and they calculate backwards how much horsepower does it take, how much horsepower and torque at certain RPMs does it take to push your car down the track. Now, if you are on a track that has a big slope, you're climbing up a hill, and you're going X number of speed. This is a two-dimensional program. This particular calculation. So when you're going uphill and accelerating, it's holding you back a little bit. So what the calculation ends up coming out with a number that is skewed, right? And so because you're accelerating so much, it doesn't know you're going uphill, so it thinks you've got not very much horsepower as you're climbing this hill, right? Opposite of that, if you're going down a hill and you've got it floored, and you use this particular function and you calculate going downhill, it thinks you've got 300 horsepower in your spec Miata if you're going down a steep enough hill, and you only look at that data in a certain spot. I use this just as again, one of those things you just got to keep in mind while you use this. If you use the entire lap, some of those wash out and we end up with enough averaging that we can kind of get fairly close, right? Is close what you're after? Is the actual number of horsepower and torque at exactly, certain RPMs, is that really what you want to use this function for? In my opinion, no. What this function does very, very well is, let's say we go out here at Miller and we've got, and my example today is going to be, we're going to talk about one car and then we're going to add cars to it. These happen to be spec cars. This was from the 2008. It was the Ford Racing Mustang Challenge Series. We had 3 team cars, and one driver was complaining that he felt that his car was down on power. And these are sealed spec engines that we can't do anything with. So this is when I really started to work this function. And as you'll see here in a little bit, the one car that the driver was complaining about, and we had shared cars during practices and testing, and his car continued to always be slow no matter which driver we put in it. So we were pretty confident, but the organizers were pushing back and saying, no, I mean, the motors are all dyno, they're spec, you need to look at some other things, right? And in the end, this data that we're about to look at is what allowed me to allow the organizers to swap an engine for us, and then got this car right back up to speed during the weekend. So I just want to show it to you. But remember, I don't really care if it says that it has what the spec cars had, which was 325 horsepower at the flywheel, minus the losses, and we're going to plug in all that information to get it fairly close. But at the end of the day, I don't care really what that number was. That's how probably the best way to use this particular function. But rather the difference. Let's say if you're a single car team, you've got a vintage car and you want to change the jets, or you want to change the tune on a newer car, go out, do a run, make that change, come back in and see if it increased the power in certain spots, or if it decreased it. It doesn't matter if it says you have 1,000 horsepower on your spec Miata, to take this to the absurd. It doesn't matter if it says 1,000, as long as you see 1,000 on one of the times and you see 1,050 on the next one, you went the right direction. And so that's what I find really important about this. Yeah, we can plug in all the right stuff and get the numbers to be fairly close, but never worry about that precise accuracy. Worry that the differences are what you're kind of searching for here, right? So let me get this back to where it's kind of out of the way, and let's take a look at the data that I tend to look for and place the way that I look for spots on the track that I want to do this calculation. Up here in the top of the box, we've got the speed trace. I tend to like to use, even if I had GPS, for this kind of a calculation where you're comparing RPM versus the rear wheel drive and the drive wheel and the force. I like to use a driven wheel, but GPS will work fine as well. So I've got a wheel speed, I've got my RPM, I've got my throttle. We'll talk about why in a moment, and I've got lateral acceleration. Because think about, if you're going to try to do a calculation, it's just as important to be at least in the same spot, if not a nice flat part of the track. But it's also important to, if you've got the car loaded, you've got the wheel turned, you're in a corner, and you've got heavy lateral G's, that's bogging the car down as well and giving you a false lack of acceleration as it's trying to do this math. So I look for, in a perfect world, I look for the lowest speed acceleration part out of a corner, and I try to find, and I only do it once the driver's hands are totally open. That's kind of where I will start my calculation and move forward. We'll talk about, you can take the entire lap, but it follows the same rules that all of Race Studio 2 does, which I have a term for, which is measures graph is boss. If I zoom in on a certain area, it only does the calculation for horsepower in that area that I'm zoomed into in the measures graph. We'll prove that point here in just a moment. And so I try to find a tight corner getting onto a flat section, and then I look at the area shown here in my bottom graph, which is when does the car at nearly zero lateral G, so the car is freed up and it's truly 100% just dead acceleration, right? Just dead on, straight ahead. Driver is to the floor. I find a spot in between the gear shifts, so we get this just clean acceleration run. Okay. In this particular case is if we look around here, here's acceleration. You look at your speed traces, you can see all these acceleration zones that we could calculate the horsepower on. But when you start to look down here, a lot of these are, this one here, there's a little bit of a turn here towards the end. There's a left-hand turn here, and there's a right-hand turn here, and a lot of turning at Miller. But the one spot where you've got a lot of good straight ahead acceleration on a flat piece of the track is right here on the front straightaway. Trouble is, as always, right? You can see here coming on to this same, this is the end of one lap beginning the other. You can see here that the driver's going through this last big left-hand corner, fairly slow, tight, almost 180-degree corner down here in the lower left. And you can see that the G's are built up here. And right about here, right about there, the driver has opened his hands fully and they're just about to shift. It would be great to do it just after this shift, right here, across the start finish line and up to this shift point, right? We'll work on that in a moment and show you how to zoom in on that. The next thing I want to do though is let's just turn on the function. Let's go through some of the settings and then we will thin down from looking at an entire lap down to thinning it down and finding that one spot on the track that's a great place to do this calculation. So I'm going to one more thing I'm going to do though before I do that is talk about making sure that you understand where you probably already know this, but here's a histogram of the RPM channel, something we haven't talked a ton about in our webinars yet, but we've looked at histograms a little bit. It's interesting though to make a note, do a histogram of your RPM channel. All you do is use the histogram function and then turn on the RPM channel as the only channel that you have active. And now this is telling us where the driver is spending the bulk of their time during this lap, right? In the RPM channel. And so if we can look at this and we can see that, here, this bin right here, and from 45, let's say 4,600 is where the driver is really going at it, all the way up to about 5,800 on the top, right? So 45 to 58 is where the driver is spending most of their time. When we go to look at the engine dyno or the calculations, engine RPM analysis, those are the number area we want to really look for to diagnose and compare, right? That's where we want to know where our horsepower is. To kind of turn this back to a couple of previous webinars we've done, yeah, but that RPM that I've just talked about there really is RPM over the entire time. There's times when the driver is off, downshifting, they're upshifting. Maybe what we should think about is maybe doing a math channel. And we'll just talk about it here. We're not going to go deep into it, but I've got one here I've created called RPM filtered. If I want a histogram of only my RPM, how much percent of a lap was, or time, histograms can go either way. I've got it set in percent of time right now. How much percent of a time, what RPM was I at, but only when the driver was greater than 90% throttle. So I've built this RPM filter channel, and it says if, we've talked about in the past, our power of if math channels, we've talked about math channels quite a bit. This is just another way of doing it. If my pedal position is greater than 90, show me the RPM. If not, make it a 0, okay? I'm just gonna click on cancel on that. And let's, instead of showing RPM, let's turn on our RPM filtered channel. And now this is a histogram showing us, and it's again, just for knowledge. So when we start looking at our horsepower torque graphs, where in that range is it really important to us, is look at this from about here. So about 4,600 to about 58, 4,600 to 58. I'm gonna make a note so I can keep that in mind. 4,600 to 5,800 is where the driver is spending most of their time on the track in this qualifying lap, okay? So when we look at our dyno stuff, this is the area I want to focus on. If the thing one motor makes a lot more horsepower than the other at 3,400, is that a big deal to the bigger picture of making time? And there's some I'd love to make more power there than the next one, but really where we're searching is here in the meat of where we're spending most of our time. So histograms, a great way of kind of leading into this function and understanding how much, where you spend your time in your power band, okay? So I just wanted to kind of show that histogram, give you an idea of kind of some things that are kind of fun to look at. The next thing I do is and I made the mistake one time. I'm going to load it, uh, and I made the mistake one time of not talking about how to get there, and I got a lot of emails. So while I just mentioned, I just used a user profile to get straight to the engine RPM analysis. The icon for that is this little guy up here. It looks like a crankshaft and rods and pistons. Engine RPM analysis. You can get there by clicking on this icon, or like always, all of the virtually all of the functions you might want to look at will always be under the view pull down menu and engine RPM analysis. Okay. All I've done is basically turn that on just in the way that we just talked about. And here's where you are going to have to go to work. Let's chat about, there's some settings that you're just going to have to go through when you first turn on this function. Everything is typically not set up correctly, and you got to do a little bit of work. Okay. So the first thing I like to do is just come over to the settings button. We need to get all these settings set up where the stuff we're looking at and the value, the data it's using, and all of that is set up for your car. Let's go through this dialog box really quickly and talk about it. Let's start in the upper left-hand corner. This set of 4 inputs are what the function uses to do its calculations. You need to tell it these things. So the RPM channel, you need to hit your little pull down menu, and sometimes it will default to, I think, data logger temp. It's the top one on your list, right? So make sure you pick your good RPM channel and put that there. And then you have some choices. Whether or not you're going to use these channels, but the more you use, the more information it has. So if you have data for these kind of things, go ahead and use it. If not, you can't use it. Speed channel, I do have a speed channel. I have choices. I have all 4 wheel speeds. I've got an overall speed, and often in your case, in most cases I do this, we'll have GPS speed. I like to use a driven wheel speed. Since we're calculating horsepower, I like to use one of the driven wheels. If it's front wheel drive, pick one of the fronts. If it's a rear, pick a rear. In this case, I picked the right rear because of the spot that I'm going to look at data here. Remember, it was a left-hand corner getting onto the front straightaway. I just always pick the loaded tire. It's just a habit that I have gotten into. We get rid of any tire spin if I'm trying to do it as I'm still got some wheel into it and the car is loaded over. I pick the loaded tire, but you're going to get pretty good answers no matter what you pick here if it's a good steady speed sensor, speed channel. Throttle position. What this is all it does is go through the data and then filter out data that's less than the threshold that you plug in. So if you've got a throttle sensor, you can plug in, I've selected 90%. It's taking all the data that the throttle position was less than 90 and not using it for math. Okay. So it's just a great way to filter out the time when you're off the throttle and rolling through some high-speed corners or on the brakes coming into a corner. It takes that out of the calculation area. So it's a great little tool. So I've got that set at 90. And then the last one, longitudinal acceleration channel. In this particular car, this is an older, again, 2008, so it had an MXL in it. It did not have a GPS sensor, and it did not have a longitudinal G sensor. So that data is not available to me. So I'm going to leave that unchecked, okay, because I don't have it. So set those on your data. So is it the question from Tice? So is it the lower threshold for throttle? It is. What that is basically doing is it's ignoring any data for the math that is below 90.0. So if you were at 89.5% on your throttle position, it's not using that data to do your calculation. Okay. So the next piece of data here is information about your car. Now it's going to be the first number you should have. It's the mass, right? And if you click, the way you change that number is you click on the 3 little dots, and it's giving you, depending on, I did see the question I think earlier in the chat box, does it matter about vehicles and some other things? If you go to File and Preferences and File and Vehicle Type, you're going to plug in if you've got a go-kart, if you've got a sports car, an open wheel car. And what that does when you do that is it sets some of these parameters for you. So it gives it a best guess. You still have to come in and change these numbers to what you have, but it does change a little bit. So so make sure you have your vehicle type set, which will help this. And this is vehicle plus driver. as you were racing out on the track. Do the best. Obviously, there's fuel burn and all that, but take an average weight of car and driver out on the track. In this case, 3,600 is what I plugged in. Okay. The next one is CX. These next two are ones that are going to be a little harder for you to come up with. I'm going to give you a couple tips and tricks about it, but the CX is the drag. And yeah, probably you don't have access to a wind tunnel, right? But if you have a production-based sedan type car, you can, there are some websites. If you just do a search for, aero drag, Ford Mustang or whatever your car is, there are some tables out there. Some people have put forums, and they've taken every numbers from the manufacturers and they've plugged them in where you can go find out the basic drag of your car. In this case, the Mustangs are about 0.38 on the aero drag numbers, and then this one has a larger wing and some other things. So a little bit more drag. So I plugged in 0.41. Well, we'll talk more about that here in just a moment. And then the front surface area is another number that you can get for production-based cars. If you're a go-kart racer or an open wheel car, the front surface area, you probably don't have that. Maybe the manufacturer of the car does. Or the other thing that a lot of people do, and you can just do a quick search on the internet. We'll talk about some ways to do it. Get down there low with a camera and maybe put something that's a foot wide or a meter wide in the picture. Take a picture and then just draw up some a grid, right, and start to count the grids. There's ways for you to calculate your front surface area. So again, those two values there, they affect the data, but they don't affect it as much as you might think, unless you're trying to calculate your horsepower at the high end, because both of those are the aero component, that the math channel that this function uses to calculate the horsepower. So if you're coming off a corner and measuring your horsepower at 20 miles per hour, those two numbers are a very, very small percentage of the calculation. So if you're doing a low speed stretch that you're running on, those do not have as much of an effect. If it's a high speed, it's 100-mile-an-hour section that you're testing and trying to do the calculation on, there's more of this coming in. So do the best you can. One last thing about how I do this is I will have engine dynos or chassis dyno numbers for the engine when it was in good shape as we were prepping the car and getting ready for events. At some point, I probably do have some engine horsepower and torque numbers. What I do is, if I don't know some of these things, I'll come in when the car was fresh and when I knew the engine horsepower, I come in and I start to tweak these numbers, and then I start to look at the horsepower and torque numbers, and I use these to tweak into the right numbers, if you know what I mean. So when you had a good correlation, use some of those numbers to back in the right horsepower numbers, and then just keep those forever, unless you change the thing, and then use those from then on when you plug in different motors or different settings, and then you can kind of trust the numbers and they kind of match. Again, as I talked about earlier, really get kind of close on these and then just forget them is another way I do it. And don't worry if the numbers are not quite right. What you're looking for is a difference, right? When you change something, you change that ECU, you change that carburetor, you change those ignition timing settings, whatever happens to be that are affecting your horsepower. You change these things and you end up getting a difference, which is really what's quite important to us. So the next one, I seen one over there. What happens if I don't have a throttle channel? If you don't have a throttle channel, you just uncheck it, and it just uses all of your data. It doesn't filter any out. So it's not a mandatory thing. The two that you really need, you must have RPM. It mandatory. You can't even turn it off. And the speed is one that I think is must. You really want to have that bit of information. The other two are just give us more information and get a cleaner result. Okay. The next column, what is shown, and what this is talking about is what's shown in the actual report up here, the actual function. Time-based curves, torque, power, and table. I'm going to pull this off to the side just a little bit. And what we're talking about there is torque. And in the upper one here is the torque of the engine as calculated. So it's the upper half of this is torque. If I were to uncheck that and press the apply button, you would see that now it's just showing us horsepower. If that's what you're after, get rid of that other one, and you see things in a little bit more granular look, right? Put the torque back and apply that. If you want time-based curves, I always turn these off, but what what that is doing is it's basically giving you a measures box, a measures graph down here. It's showing you the same channels that you've turned on and are using up here as a time-based curve. So I tend to not use that. It just compresses everything. So I turn those off. And then table, the last one we haven't talked about, is do you want to have this nice torque, horsepower torque dyno sheet kind of a look to it. And at this RPM, this is what it was calculated for horsepower and for torque. I like to leave the table on as well. Okay. And then finally, curves and points. Let's apply that just so it's there. Curves and points. You have all of the data points where it's been calculated, and then it does a kind of a best fit around it with a line. So we can turn off all the data points and apply that, and we just end up with the horsepower and torque graphs. And over here on the left side, it's the scale, and on the x-axis across the bottom, it's the RPM. Okay. I tend to leave the points on. I like to see the density and how many points are in a certain area, just for my own mind. But you can turn those off as well. Okay, so this is about where I use this, right? These settings box right here, you must do this the first time you do it. It will remember it down the road, and the next time you bring in that same car, it will use these same values. But boy, the first time you do it, you have to go through this, and you have to get it, bad data in, bad data out kind of a thing, right? So if you're using your oil pressure as your RPM channel, you're going to get some odd numbers. The last one over here is the scaling and the values, right? In other parts of the world, they like to see Newton meters as their torque, and they like to see kilowatts as their power units. Here in the States, we use typically horsepower and pound-feet of torque, and so that's what I've got it set up. But you can select the units you want to see, and then this doesn't work as good as our measures graph. You can't just come over here and double click on the y-axis and get this to auto scale. So what I do is I usually just start high, put in a 500 depending on your car, and run it once, see what the numbers are, fine tune things, get it where you want it, and then come in here and fine tune these numbers one last time to kind of where it fits as good as possible into the graph here. So do your best guess a little higher than what you expect to see on your horsepower and torque numbers, and plug those into this box as well. Okay, and let's apply an exit to all of those settings. Okay, so now we've got this thing kind of built, and here's the next thing that I would want you to look at while you're setting these things up. Look at the values over here in our table, right? You see how they're not nice little 50 RPM bins or 100 RPM bins, and across here they are, right? Here we've got 500 RPM graphs down across the bottom, but over here these are some odd numbers. 3817 to 3875. It made this. That, for most of us, we want to see on the 50 RPM or the 100 RPM increments, right? Here's a little bit of one of those things you just got to know about the function, and it really does help you when it comes time to use this. Is if you want to see 100 RPM increments, here's a little bit of the background, a little bit of maybe behind the scenes stuff, but this table always shows you 60 bins. There's not you can't right click, come up here to settings and change this. It's 60 bins, and because of that, you have to think about the scaling of your RPM channel in order to see that. And the way that this works is if you use a 6,000 RPM range, right? 3,000 to 9,000. That's 6,000 in between, right? You will have 100 RPM increments on your table. If it's a narrow RPM range, maybe you go down to 3,000 RPM on your RPM range, and you get a 50 RPM range in the table that you might want to print out, save to Excel, print it out, do whatever you want to do with it, look at the numbers. That'll typically match most dyno sheets you have to make that easier. So over here, I just right clicked on the RPM channel. I brought up the measures information. Mox could have clicked on the wrench and a couple other ways to get to this, but so I'm going to come in, and instead of 3,000, 6,500, maybe we do 3,000 to 9,000, right? And let's apply an exit. Immediately, see, this has now been updated, and we've got these in 100 RPM bins, and the lowest, if you're going to get zeros if in this lap the driver never was from between 3,600 and 3,700, it's going to say 0 horsepower. Really what that means is that you were never there while you were at 90% throttle and all the rest of the things you told it, right? So we can start to search and look into this and begin to look at the data. We'll kind of dig up here a little bit, about maybe here. So remember we talked about 4,600 to 5,800 was like the sweet spot, and so we can come down here to 4,600, and there's your 262 horsepower in this particular calculation, and up to about 5,800. That's where the driver's spending most of the time. Okay, that's one thing. The next thing that we talked about is zooming in. Measures graph is boss. I want to do some calculations. This is taking the entire lap and doing taking all that data, throwing it in there, and averaging the entire thing. There's value to that. But if you've got a track where it is nice and flat, and you got 0 G's from your steering wheel, 0 lateral G's from the driver inputs, I would rather thin this down and just get a nice acceleration run. How do we do that? We bring up the measures graph and we just zoom in. I'm going to zoom in on this little area right here, right? And this is the 3rd to 4th gear run right here. I've got my throttle position up. I've got my lateral G's. I can see that the car is nearly 0. Full throttle. I can see where it was higher on the RPM. Here was a shift point. I'm going to continue to zoom in. I'm going to zoom in on this little area right here. So I'm going to use the zoom tools just after the throttle goes to full and before he lifts again, and you end up with this little bit of data here that is just very, very clean now, and it is 100% just a straight hard acceleration run with no additional factors. It's a flat part of the track, and on and on. So we can come down now and look at this data, and here's the horsepower it made when the driver was just in 4th gear. I said earlier that I like to actually even look at the data at the lowest speed that I can, where the car is straight. In this particular case, it is being split by the lap, by the start finish line. So I've got part of that over here, right after this little gear shift over here on the right side of the screen. I'd love to do this data, in the 2nd gear to maybe it's 3rd to 4th. I'd have to look at the gear position, but yeah, this is 4th gear. This is 2nd. This is 3rd gear, but there's still some G forces here that I want to kind of stay away from. So I'm going to look at this area right here, but it's being split by the start finish line. We've talked about this in the past. This is where we get our snap function comes into play. Remember, if I hit the snap button, it allows me, this data now is floating. It's no longer constrained by the start finish line. So I'm going to pull this over a little bit, and now I can do my math in this nice little section of this 4th gear run right here. So I'm going to use my zoom tools, and I'm going to zoom in now that I've done that, and I'm going to go right across here. And here it introduces I'm not sure if it's a bug, or I think it is, but notice that I zoomed in, but there is still a ton of dots. And here's the next of the things that it makes this, you need to understand this in order to make this work as best as possible. For whatever reason, when we leave it in distance mode, it doesn't seem to thin the data out the way it should. So using the time mode, when you're in snap, it only is a matter when you're in the snap mode. It's a bit of a bug. We're working so hard on Race Studio 3 that we're probably not going to come back in and take a look at this. But the workaround is to go to time mode. And now all of a sudden I can I've got the shift point here. You can see some of these dots are floating around here because this is a shift. So I'm going to zoom in a little bit more yet again, and there's my shift point. This is when the RPM settles down. I'm going to go a little off of that, come up here. There's where the driver lifted. I'm going to pull back just a little bit just to make it fairly clean. Now here is my best shot, as I've used this thing quite a bit, to get a really good horsepower and torque values of this motor as it sits out on the track during this run. It's the lowest speed when he's on a flat section and going straight ahead. So we're getting the max, the best acceleration rates we can see. Takes away as much of the aero effect as we can get rid of. I don't know if there's a headwind, things like that. I don't know as much. So I do everything I can to get it back down to the lower speed if possible. That's how I do that. Okay. The next thing though is how do I, this would be great if I'm a one-car team and we're looking at this data. Yeah, I get it. I can make a change, go right back out, maybe come on a pit lane, make some quick changes, go right back out and compare laps. All good. The thing that I want to do though is, let's jump back out of this and go all the way back to kind of standard. We had 3 team cars. One driver was complaining about power. Let's talk a little bit about that and see. Let's compare these 3 team cars and let's take a look at the horsepower from each one, and let's see what it shows. This is like, as I mentioned earlier, this is where I kind of really enjoyed this function. I was able to begin to trust in it if we do these certain little things that we've been talking about today. Andy has a question. Does this work better if you can talk the driver into doing a single gear sweep from say 2000 to redline? Certainly. A lot of people that watch these as they're driver owners, but if you are engineering a car and you really want to get that, go ahead and have them come out of a slow corner and just put it in that direct gear or whatever, 4th gear, wherever it's close to 1-to-1 if you want, and just make that good hard solid pull. But I'm going to tell you that I almost would rather the driver just go do what the driver does, and then I find that spot, right? And if I want to find that lower RPM spot, and that's the way the driver drives it, more power. But if he's never at 2000, I don't care much about the data at 2000 if the car is never there during the competition. So back to this, we've got I've got my son Andrew's Mustang here from there, and then he had a couple of teammates, and so I'm going to go ahead and open those 2 cars as well now. Boom, boom. And then let's bring up that stuff back to the front. Now we've got the 3 drivers all lit up here. We've got a blue, an orange, and a yellow. Let's change that yellow to maybe a green color just to make it a little bit easier for us to see. And and now this is the entire lap again, right? And we've got RPM, horsepower, and torque for 1 car, 2 cars, and the 3rd car over here. Okay. Let's do what we did just a minute ago, and let's dig into the area that all of them are at 0 G's laterally. They're all flat to the floor, and try to figure out and get our best guess of what the horsepower is. And that is, of course, back here where we just talked about, where it splits the start finish line. So first thing I'm going to do is go back to my snap mode, turn that off so I can look at the data. Hey, here's a little trick. I think I've mentioned it once during one of these webinars. When you're in snap mode, you of course have an x-axis for every car. And if you come down here, and you'll begin to love this tip I'm going to give you. If I come down here, I have to pull each car over individually, right? You see this? And then I'm just bringing it over, and now I have to realign them, kind of, whatever, and to get them to line up. And I had to do this 3 times in order to get the 3 of them lined up. Any of you use the snap function fight this when especially if you're moving off your screen. This little tip is pretty cool. If you push and hold the control button as you are about to try to drag these laps left and right, if I push the control button and then grab any of the 3 in this case, and then you can drag all of them. Okay. Very, very handy little tip when you start using the snap and then moving things around a little bit. Okay. So now that I've got this kind of isolated out here where I can see both sides, but having the snap mode off, now I come into my my zoom tool, and I always zoom kind of close, right? And I do a double zoom. So I'm just going to kind of get in here and just get myself into the area, right? Okay, here I'm kind of close, and what I really want is right about here, right after all the drivers have done their shift, and then up to the spot where the drivers are doing their shift again. Now again, here we are. Remember, if you continue to see a lot of dots, even though you've zoomed in this function, it's because in distance mode, it has a little bit of a problem with that. So go to time mode. You'll see it automatically has thinned that down. It's used the rule of measures graph is boss. And then now I want to really zoom in on this little area here. So let's use our zoom tool again. Find that spot where the driver, all three, these dips here on the throttle position is the shift points, obviously. I'm just gonna go up a little ways from there. I'm gonna click and I'm gonna drag. There is the first person that shifted, which was the orange car. I'm just gonna pull back from that a little bit. I wanna just get a nice clean area. And now all of a sudden we've got this horsepower curve for the three cars. And the backstory here is the green car was the car I mentioned earlier, where everybody that drove the car, that car was always a little bit slower on lap time. And it wasn't just the driver, because we would put different tires on it at first, and we'd do some tune-up stuff, try to make it handle well. Then we started to swap different drivers into it, and that car was just always a little bit slower. And so we were pretty concerned that the motor was the problem. That's what it looked like in the data. So then I did this particular function, and now you can look. Remember that 46 to 5800 is where we're spending the bulk of our time. So let's look at like 5000, 5200. Let me bring that up. And so if we look at let's see, is this the 5000 or so I'll put that right here near the top. And the first car it was 262 at 5,000, right? Right in probably right in this area right here. And 262, 265 for the middle car of calculated horsepower, and 251 for the third car. And you can kind of see that the green one is the one we're concerned about. And look how when it comes up here, I'm looking at the torque here, but the power here, you can see that it is down. It comes back, and towards the end of it, it ends up being pretty good. But boy, it spends a lot of time 10 or 15 horsepower down. And because of this was something that we were able to look at on multiple sessions, multiple laps, and seeing this trend happening all the time. Plus, of course, the driver's complaint of lack of power, and swapping out drivers. This was the final straw of, we've got some data that pretty much shows this, and we were able to go to the organizers and say, this motor is weak for whatever reason, and it was a very rare thing. The series had done a fantastic job, but there were in the end there were 2 or 3 that they found that there was I think it was a thrust bearing problem that was pulling down the power a little bit as a thrust bearing had worn on certain motors. So this was very cool. We were able then to swap out the motor and have them give us a different motor for the car, put it in, and immediately the horsepower came right back where it belonged, and was a match within 2 or 3 horsepower of the rest of the cars. This was the function. This was the actual application that taught me about this function and how it worked, and how it I was able to get good value out of it. So keep that in mind. If you have some questions, start to put those in there. I'm gonna do a poll or two here, and then we'll back out and look at some bigger numbers, and then and answer any questions about the function a little bit more. But we went through a couple of things. We basically looked at what data is important to us, with speed, RPM, throttle, lateral G's. We then talked about how to set up the dialog box, and then we talked about how to use the zoom tools and the snap and the distance and time to get to the data. Think about what you're doing, and consider exactly what data pieces you want and where in the data you want to make your calculation, and use that whole function just like the rest of Race Studio, very pretty consistently. Measures graph is boss. If you want to look at a histogram and only look at the data is in a certain area on the track. You want to look at one corner for your shock sensor and velocity data. Zoom into that corner. All the rest of the functions only are using the data that's being viewed in the measures graph as your calculation. And we're doing the same thing here. We've calculated into a very specific spot on the track that we think we get the best shot of getting a good, accurate calculation. And then that's what we use. And you'll see that work really well. Good question. Two questions that we'll chat about. With a no lift shift, long G would be needed to find the best place to zoom since TPS is 100% during the shifts. True, David, but longitudinal G, it's just adding that as value. If you had a no lift shift, you do not have to worry nearly as much about zooming into an area where the horsepower to the rear wheels was interrupted, right? You wouldn't need to zoom in at maybe quite so tight. Having longitudinal G will add some value, but it's not mandatory. You would just end up with being able to zoom the entire front straightaway, right? Or up to the spot where aero really takes effect. Maybe you'd want to thin some of that out. So good question. The other thing that I'm glad, Stefan, that you mentioned it, where can I find your RPM filtered channel? One of the things that I do a lot though is instead of using the settings of it's a little slow popping up here. Hopefully it'll pop. There we go. Instead of using the MRPM channel, which was the raw channel, is maybe I come in and maybe I use the RPM filter channel. That's basically doing some of the same stuff that the pedal position is doing, but you could do it there as well if you don't have a throttle position, or you filtered the throttle with longitudinal Gs. You might be able to use that. And one last tip as we're kind of closing out of the technical and the little areas where you might run into some headaches, every once in a while on cars with ECUs that maybe sample the RPM at a very slow rate. And every once in a while, you'll see all these dots are just the data points every 20 samples per second or whatever this ECU is giving us. If I were to zoom in like crazy on this RPM and make this band very narrow, at some point the math of the function might drop down to 0 and back up. You'll end up with these lines in your torque curves where they keep jumping down and back up, and it will skip 5,900, maybe in this case, that's all the RPM that he was at. He wasn't at 6,000, but every once in a while, even though you were at 6,000, you'll get a 0 value because it's calculated it so fast that the data points in the data actually didn't give it any numbers at 6,000, let's say. If you look at yours, when you do this down the road and you see this coming across here and all of a sudden it goes down and comes right back up with part of the line work, right? If you see that, here's a kind of a cool little tip that you can oversample your data just for this function. I'm not sure it has a value at a whole lot of other places, but if you come into the math channel function, and let's insert a brand new channel, and I'm just going to call it our RPM oversample. Look at that, I typed right. And if you come in here and all you do is add the RPM channel to it, right? Just that. And I come in here and I say it's RPM, your normal math channel functions you do need to do. And let's say it's 6,000 is where for the high and 3,000 for the low. All you're doing is setting your scaling here. But here's where you do kind of a trick. If your car is only sampling at 10 samples per second and you have those little dropouts in your calculations, you come in here and oversample it. So basically it's just taking each dot and then putting dots in between and averaging in between, right? It's just calculating the value would be in between, even though there wasn't an actual hard sample there. Sample this at 50 samples per second. We only need to see it with no decimal places, and come in here and save that. And what you've basically done is you've oversampled an RPM channel. We're not going to go deeply into that beyond that, but if you have these little dropouts, now just go in and pick your channel that you have now created that is an RPM channel that has 50 samples per second instead of 10. Yes, many of them are interpolated, but it gives the programming a a value at the RPM in order to see that at, every 50th of a second instead of every 10th of a second, where it doesn't get those little dropouts. So you could come in here now and grab, instead of the one that we built there, we could pick RPM oversample as our RPM channel, and you get rid of those dropouts. Just another tip: if you're using this and you've got a really slow RPM connection, you're getting these little dropouts during the math here, maybe oversample the channel as a math channel. I think you'll find that that's a valuable tool as well. Okay. One last thing, as I'd like to do a couple of polls. I see some excellent tips and other stuff. Thank you guys very much. These are things that we learn as we use these things, and just yeah, they're great little tips, but they're workarounds, but they are great little tips. And just think yourself through as you use the data of, boy, what's it doing? How can I work my way around that? That's the way I end up doing it all the time, right? I'm gonna do a poll as we've kind of done this. I'm going to launch the poll real quickly as I start to look over the questions, and we'll start to answer them. You have, when analyzing your data, what functions do you use the most? If your functions is not shown, please list in the chat box. These help us as we figure out what things we want to look at into the future and continue to talk about. Any hot tip how to align those multiple X's? Yeah, there you go. Pekka, one of the things I do, and while we're letting that graph run for a minute, if it's in your way, maybe slide it off the side. I think once you submit it, it moves out of the way. See this orange line? That car was slower, right? Maybe it was faster. And so that data maybe isn't aligned all that well in our graph. One of the things I do a lot is I come down, and now without the control key, you can individually move these. Here's a little bit of a weirdness to it. I want it to move to the left, maybe get to the RPM. So by shifting that x-axis across the bottom, we're trying to find that exact same RPM range, but maybe not exactly on the same spot on the track. I'm comfortable with doing this on when the track is very flat. If you're doing this on a slope, or a slope is starting during your run, you would want to have all the cars at the track on the same spot, right? In that case, you open up your GPS map and you align everybody with the X's in the GPS map. That puts everybody at the same spot. In this case, the orange one has got a bit of a shift to the right, and I believe if I pull this to the left, just his number. Oops, and I went the wrong way. Pull it the opposite way of it, and I'm just dragging the orange trace just a little bit, and pretty soon you can get these things to align pretty well. It's not terribly important, but if that's important to you, you got a really narrow range, and one car was in a different RPM range at that same spot when we zoomed way in, this might be something that's worth doing. As you move these little x-axes across, you can actually kind of get the numbers to line up a little bit better. The values are still the same at 4,800. It's just that you're grabbing more or less data on each side of the RPM range. Okay. Let's end that polling here for a second, and we'll look at some other questions here in a second. Let's end that polling and let's share that so everybody can see it. The answers there, measures graph, 92%. It's multiple choice. We spend most of our time in the measures graph. That doesn't surprise us, right? But I'm glad that you're all recognize that. The next one is channels report, 62%, and I agree that channels report is a valuable tool. Very quick especially on the vehicle health thing, to look at your high and low RPMs and high and low oil pressures and voltages and such. The next one, but as a tie at 54%, split report. And the time compare bar. Time compare bar being down here where I've got it turned off here, but with the snap and the time on. But time compare being at the bottom, again, one of those core functions of the software. If you're not using the time compare a lot, you ought to be. So I'm glad to see that built into the measures graph, and the split report. Perfect. And math channels, is the next one there at about 44%. Thank you for that. These again allow us to, what do we focus on as we do these webinars? And as I mentioned before we actually started the recording for YouTube, we're gonna do these webinars right now. I'm starting to plan the dates out all the way through the end of the year. So we're gonna be here through the bulk of the winter, when a lot of you maybe have a better chance of watching some of them live as well. So let's stop sharing those results, and I'm gonna fire up one more just for fun as we answer a couple more questions on our way out. So Let's launch that one. Um, when you look at your data at the end of the day, what do you look for? What's kind of important to you? It's multiple choice, so specific issues about the driver of the car, curiosity, looking for areas of improvement on a particular spot. Take a look at that and let me know what you think. Um, the Kyle, any other metrics or math channels you could use to evaluate engine performance outside of this function? There is a number of different things. How would you evaluate engine performance over the course of several laps? What I did is I looked at. I'll get to the first part of your question. The second part is multiple parts of multiple laps. Take your own data. Many of you are one car team and owner operators, and bring up 8 or 10 laps of your own. 2 or 3 early, 2 or 3 in the middle, 2 or 3 late when the engine's getting hot, heat soak, or whatever it is that you're concerned about, but it's maybe pulling some horsepower out, and stack them up the same way I did with 3 cars, and start to look at the numbers. And did it lose horsepower at the end? The lap times are dropping off in a theoretical here. Your lap times are dropping off. Well, is it because of cornering speed? Is it because of horsepower? Is it because of horsepower at a certain RPM? This is a great way. Look at multiple laps in your single car data. Are there other metrics or math channels? I did see an earlier chat that talked about we do have an AIM wheel power math channel. I actually was thinking about doing that. I loaded it and started to work with it and make sure that we were ready to talk about it. And I figured I had enough time on this function that I didn't want to jump into it, but we do have some of those. Right now, I think its core is to give it to you in kilowatts. So I need to adjust it to output in units that we might want, horsepower here in North America. But there's that. And then there's the old standby, which is looking at just acceleration rates, bring up the speed traces from the 3 different cars, or your car early and late, and then look at. Let me close that down. Let me maximize this, and let's turn off a little bit here. Let's do this, and let's do this and this. Here we are, just back to the normal, and I'm going to turn off everything but the speed trace for these 3 cars. And let's say that let's just pick this from the start finish line up to here, right? The delta function is a great function. If I just come in here and I click up here, towards before everybody breaks, what it's telling me is in the area that I just clicked, number one, the first value is the second click, right? That's the miles per hour of all the cars. That second column right there is the miles per hour gained from the first click to the second click. It's acceleration rate in effect, right? So the blue car accelerated 27 miles per hour from about the start finish line, or wherever I clicked, up to the braking spot at Miller. The orange car gained 1 mile per hour less, 26, and the other car was gained 1 less mile per hour or the green car, 25. Another real quick way of looking. I like to look at that diverging and converging speed traces for acceleration rates. So, and if you start it late enough, you can get rid of the driver that got through the corner the best, right? Because if you did it right here from the apex, the orange car actually will have accelerated the least amount. If I just do it real quickly, if we come back here and right about starting right here maybe, and then up to where they lift, now that orange was the by far the best in that run, right? But it shows he only gained 29 because he had such good exit speed. So you got to be a little careful. Pick it where the car again is straight and is accelerating, and it will give you the best answer towards that. Let's end that polling and let's take a look at it. Let's share it on our way out here. Last little bit of slides. You look at the data, what do you look for? And it's multiple choice. The number one, looking for areas of improvement on a particular part of the track. Kind of what we did here a little bit today, right? We picked that one area and we zoomed in on it and we started to study it. 93%, that's how you use your data. That's very good. 86%, specific issues you may want to understand. You've gone out and you drove the car, and boy, you say, on that high-speed left-hand corners, the car is a bit of a problem, and you start to study those things. Or gear ratios, or whatever it happens to be braking, you're looking at those areas. That's 86%. Nicely done. Comparing my performance with the last time I was at the track, a powerful way of using data. You download your data every time. Sometimes you don't have a ton of time to look it over, but boy, it is very good when you last time you were there, and you had good speed, good results, and then now all of a sudden you go back for another event, and you can't quite, you've lost a couple of seconds on your time. Boy, it's great to bring up that previous data file and overlay it and say, am I losing it in the corners, the straightaways, the acceleration zones, the braking? Where am I losing my speed? And then you know where to work. This is the powerful part of data. So that one was 52%. So very good. I appreciate you guys doing the polls. That's always powerful for me. Always powerful. Let's see. One last question before we jump out. Roger, maybe I missed it, but what is the value you're looking at in the horsepower torque all around the track? I saved a user profile, another great tool, great user profiles for this. So I've got one here that it's all set up, right? So boom, user profiles, you can compare each driver, or you can put all on top of each other. And now you've got the horsepower all the way around the track, as Jim is asking for. I think we maybe did chat about that earlier. So now you can look at that 5,000 RPM range and get an understanding of that. Let's put it right there, which is where we want it. I always like to just drag it up to top so I don't lose myself. So and by the way, if you have multiple cars, the order that you're seeing them here is the order that you open the test. So Caddell is the first column, so 269 on the horsepower. The second one is Terry Borscheller at 270.2, and now we're averaging over the entire course, right? Minus when it was less than 90%, because that's what we told it. And that third car that we've been complaining about horsepower, 257. So there's your overall lap average of when it was out. Still down. I just feel more comfortable when we find that one spot where we can really get rid of all the fluff. So okay, perfect. I don't want to keep you any later than what we already are. I appreciate it, everybody being here. Let's jump back to our presentation real quickly. Let's talk about what's coming. Of course, this video will go up on our YouTube. This will be number 118 of the series. We're going to continue to build these. Got a lot of good traction, get tons of good feedback. People just love going back and watching them when they have a specific question. If you need to, maybe someday we'll look at things that are available to you as training and support from AIM. And one of the things on the YouTube site, you can go in there and do some specific searches for words, so you don't have to look at every title and guess where things are. That's pretty helpful. So maybe we'll do that someday. But 118 videos up there ready for you to take a look at. The customer support, we've got three of our AIM techs here, and everybody else is traveling. So I know Robbie is traveling up here north to the Washington State area. He's in the air, I think, right now, coming up for a large Formula Drift event at Evergreen Speedway. I'm going to head up there on tomorrow and work with him on with some of the users. So looking forward to that. I'm not traveling out of the country, but out of my area. But I will be able to go and do a trackside support, so that'll be fun. Robinson heading to Crandon, Wisconsin for their makeup event there. That'll be very cool. The next webinar, we promised when we first started these that we were going to do these Race Studio 3 beta analysis about once a month, every 3 weeks to 4 weeks, as we could fit them in correctly. And there has been an update just yesterday on Race Studio 3. If you haven't done it, make sure you open up your beta software. If you're in the public beta version, open that up and update that. Make sure you have the latest and greatest. And we're going to talk about that tomorrow. Some of the bug fixes that they've done, the enhancements, new features, stuff that's coming. Emiliano will be with us co-hosting again, and that'll be on Tuesday, September 29th, same time as always, 10 a.m. Pacific, 1 p.m. Eastern. And we'll talk about our fourth installment, or our fourth episode of Race Studio 3, and giving you an update on the beta software. A lot of the stuff that they've been fed back as far as enhancements and bugs and things that they've fixed and stuff that we're seeing. So look forward to seeing you all there. And again, as I mentioned earlier, we've got been chatting with a lot of different people about upcoming webinars, and I think we've only probably got 3 or 4 open slots from now to the end of the year with a lot of new and exciting guests that we haven't had yet. A few that we have as well that will be welcomed back. So looking forward to that. Hope you keep up with that. Thanks for coming, everybody. Oops, darn it, I went too far. There we go. There's my contact information. I love the engine RPM analysis feature. It has a couple little quirks that you just need to be able to work around. If you have some questions about it, there's my contact information. I'd love to work with you and make sure you're getting value from this channel. And some of the feedback we get, we'll pass it along to Italy and the software guys, and we'll have this same feature in Race Studio 3 at some point, and we'll fix a lot of the stuff that we talked about today, I'm sure, and make it work even better. So thanks everybody for coming. I appreciate it. Looking forward to seeing everybody here next Tuesday. Thanks for coming. Have a great weekend. Hope you're going to the racetrack, and we'll see you next week. Talk to you soon.